In the realm of warfare, few inventions have left such a permanent mark as the atomic bomb. But what exactly is an atomic bomb, and how did we unlock its devastating power? To understand this, let's go back to humanity's first successful attempt at a nuclear weapon, the Manhattan Project. The time is 1942, and World War II was in full swing. The nuclear bomb was now understood to be a new possible weapon of mass destruction. As there were fears that Nazi Germany would try to develop an atomic bomb of their own, the USA responded by funding its own project, the Manhattan Project. This was a secret effort that brought together the brightest scientific minds of the era in a quest to develop the world's first atomic bomb in a race against Nazi Germany. The principle of a nuclear bomb can be explained by Einstein's famous equation E = mc². Put simply, Einstein's equation shows that the energy of a single object is equal to its mass multiplied by the speed of light squared. The speed of light itself is a very large number, being 3 × 10⁸ meters per second. Therefore, an extremely large amount of energy is released even if a very small mass is used. J. Robert Oppenheimer was the director of the Los Alamos laboratory, where the atomic bombs were designed, and after $2 billion, or around $30 billion today, 2 types of nuclear weapon were developed. A simpler gun-type fission weapon, and a more complex implosion-style nuclear weapon. The gun-type fission weapon, as its name suggests, involves shooting a piece of subcritical material into another. Subcritical simply means that the pieces of material are not large enough to sustain a nuclear chain reaction on their own. However, when they collide together at high speeds, a supercritical mass is formed, and a chain reaction occurs. The other type of nuclear weapon that was developed was the implosion-type nuclear weapon. This is more complex than the gun-type weapon, and it uses a series of explosives which simultaneously explode, causing the mass to reach supercriticality through implosion. The design of nuclear weapons has been evolving ever since the success of the Manhattan Project. One of these evolved designs is the thermonuclear weapon, or H-bomb. Thermonuclear weapons use not only nuclear fission, but also nuclear fusion to create an explosion that is hundreds to thousands of times more powerful than an atomic bomb. The exact design of a hydrogen bomb, obviously, remains a state secret. However, in simple terms, a hydrogen bomb works through the following steps. Step 1. A relatively small fission bomb known as the primary explodes. Step 2. Energy released in the primary is transferred to the secondary stage of nuclear fusion. This energy compresses the fusion fuel which undergoes nuclear fusion. Step 3. The energy released by the nuclear fusion reaction continues to heat the fuel, sustaining the reaction. Step 4. The fusion fuel may be surrounded with a layer of additional radioactive material, which undergo a chain reaction when hit by neutrons released by the fusion reaction. The combination of all of these steps creates a nuclear weapon that is far more powerful than the original nuclear weapons used in World War II. The first thermonuclear weapon, codenamed Ivy Mike, is estimated to have a blast yield of 10.4 megatons of TNT. As a comparison, Fat Man, which was dropped over Nagasaki in World War II, only had a yield of 21 kilotons of TNT.
На D8 включается программный автомат аппаратуры опытного поля. Брос! 3 секунды. 2, 1, 0.
Now let's talk about the biggest nuclear bomb ever detonated, the Tsar Bomba, literally the king of bombs. Despite being from 1961, the Tsar Bomba still holds the record for its mind-blowing blast yield between 50 to 58 megatons. The explosion created a fireball that was 5 miles wide and a mushroom cloud with a height of 42 miles, which is nearly 8 times the height of Mount Everest. Nuclear weapons have been extensively developed since the Manhattan Project, and it is estimated that there are around 12,700 nuclear warheads in the world right now, with the US and Russia having more than 5,000 warheads each. Even though these nuclear weapons are less powerful than the Tsar Bomba, they would still cause a devastating explosion if used. Furthermore, bombs no longer need to be dropped by planes, and the development of ICBMs mean that nuclear strikes can now be carried out from anywhere in the world. As Einstein once said, "I know not with what weapons World War III will be fought, but World War IV will be fought with sticks and stones.